In this video, I'm going to be doing an average rate of change problem. And in this particular problem, we're going to use the difference quotient. So remember, the difference quotient looks something like this. We have f of a plus h minus f of a all divided by h. Now, this is really just another version of our average rate of change formula, which is f of b minus f of a all over b minus a. And in another video, I demonstrate how these two formulas are related. But in this particular case, we're going to want to use this version of the formula because we're going to be using different values of h. And by using this formula, we don't have to do the entire problem completely from scratch. So in this particular case, our function f of x is the equation 27t minus 24t squared. Our a value is a time, and the time right here is 1. So now we're going to call it, for the sake of this formula, a is equal to 1. And we want to use an h value of 0.01 and 0.05. So our interval is essentially from 1 to 1.01 for the first part. And then using this, our interval is from 1, always starting at the a, and going to the a plus h, 1.05. So in other words, these intervals are in the form of a comma a plus h, right? So to use the difference quotient, we're simply going to set it up using that formula. So we want to start with, I'll rewrite the formula here so we can see it. F of a plus h minus f of a all over h is going to look like this. So we have f of 1.01 minus f of 1 all over 0.01. And again, I'm doing the first part here when h is equal to 0.01. That's what we're doing now. Well, the actual function then is going to be 27 times 1.01 minus 24 times 1.01 squared. And I'm going to put that in brackets. That's this part right here, minus, we want the f of 1, the function value evaluated at 1. So that's going to be 27 times 1 minus 24 times 1 squared. And then all of that is being divided by my h value, which is 0.01. Now, evaluating this, you can do it by hand, but I would suggest that you do this first part right here, this part, using Desmos. So I've plugged this into Desmos, and it looks something like this. 27 times 1 plus my h value, which is 0.01, minus 24 times 1 plus my h value squared. And then it gives me a slider. It asks if you want a slider. And I made a slider, and I let h be equal to 0.01. And so when h is 0.01, this whole quantity becomes 2.7876. 2.7876. So we get 2.7876 for this, minus, well, this just becomes 27 minus 24, or 3, all divided by 0.01. And now we're going to end up with a negative number. 2.7876 minus 3, and then divided by 0.01, this whole quantity becomes a negative 21.24. And that would be the answer to the first part when h is equal to 0.01. Now, to do it when h is equal to 0.05, we simply redo this part. So we're going to have 27 times 1.05. This is when h is equal to 0.05 now. Minus 24 times 1.05 squared. Minus, and this part doesn't change, the 27 times 1 minus 24 times 1 squared. This part will never change. And then it's all being divided by 0.05 now. Now we can do this hard part here going back to Desmos and using the slider. So going back to Desmos, I'm just going to change the slider from 0.01 to 0.05. And so now it's letting my h value be 0.05. So that is now 1.89. So this whole first part becomes 1.89. And again, this is going to be minus 3. And then divided by 0.05. So let's just go to Desmos and see what that's going to be. 1.89. I'm just going to do that down here. 1.89 minus 3. And then if we put that all in parentheses and then say divided by 0.05, our answer is negative 22.2. Negative 22.2. Now we could do this for negative, let me write that down. Now we could do this for other values as well. We could say, well, let's let h be equal to 0.00001. And the only thing I need to do is all of this part is done with the slider. So I'm going to go back to the slider in Desmos. And I'm going to let that be equal to 0.00001. I think I have four zeros in there. Is that what I had? Yep, I had 4 zeros. So now the first part becomes 2.9997. So we have 2.9997. And remember, the second part of this formula is always going to be minus the 3. And now we're dividing it by 0.00001. So I can easily go back to Desmos. And let's get rid of that. Put in the 2.9997 minus 3, and then divide that by 0.00001. And the answer is negative 30. All right, so this is why using the difference quotient can be very, very helpful rather than using the traditional formula f of b minus f of a, because if you were using this, you'd have to do the whole problem over again. Whereas with this particular method, especially using Desmos, all you have to do is recalculate this in Desmos, and that's where the bulk of the work is.